Okay, so positional isomerism. When the position of the functional group changes, it has the same molecular formula, structural formula change হচ্ছে আমার functional যেই গ্রুপটা সেটার position change হওয়ার কারণে. So what are the functional groups that we have? We can have alkenes, alcohols, carboxylic acids, aldehydes, ketones, and a whole bunch of other stuff like nitriles, amines, esters. These are all within the scope of our syllabus. So let's just talk about the basic ones. Alkenes, alcohols, এসব জিনিসপত্র যেগুলো আমরা আগে শিখছি. তো alkenes কি জিনিস? Alkenes এর মধ্যে ডাবল বন্ড আছে. There is a carbon carbon double bond in alkene. এখন ডাবল বন্ডের পজিশন চেঞ্জ হতে পারে. So imagine a scenario where you're working with hexene. So hexeneের মধ্যে what are the possibilities? You have 6 carbon atoms. এখানে 5টা বন্ড আছে, একটা, দুইটা, তিনটা, চারটা, পাঁচটা কার্বন কার্বন ডাবল বন্ডস. Everyone else is hydrogen. All these empty hands are hydrogen. I'm not going to fill them in. তো এখন ফার্স্ট বন্ডে একটা ডাবল বন্ড, এর জন্য we are going to call it hex 1 in. সেম জিনিসটা আমার যদি ফার্স্ট জায়গায় না হয়ে সেকেন্ড জায়গায় হইতো তাহলে we would call it সেকেন্ড ডাবল বন্ডের মধ্যে আছে. This would end up being called hex 2 in. সেম জিনিসটা এখন আমি চেঞ্জ করে দিছি. এখান থেকে we have removed it over here. So 1 to third double bond from this side, 1 to third double bond from this side, right side, left side, both sides is going to be the third double bond. So this is going to be called hex 3 in. If I move a bit further, I'm going to get a double bond over here. This might be called 1 2 3 4, so hex 4 in. Othoba if I count it from the right side, it's 1 2, so this is hex 2 in. So I'm going to simplify. I'm going to take the shortest side every single time. So this is going to be called hex 2 in. Take it a bit further and we now get hex 1 in again, karon this is the first double bond from the right side. So this is how we name this is how we create functional isomers where the main functional group is changing its position. এখন এই জিনিসটাই এখন আমাকে ব্রাঞ্চ চেইন আর ফাংশনাল গ্রুপ আইসোমেরিজম দুইটা একসাথে হতে পারে, চেইন আইসোমেরিজম, ফাংশনাল আইসোমেরিজম. সো how many possibilities can we get? We can have carbon carbon double bond over here, 1 2 3 4, and this could end up being a CH3. What am I going to call this guy? কারণ এখানে তো একটা মিথাইল গ্রুপ আছে আবার একটা ডাবল বন্ড আছে, তাহলে there is going to be 5 carbons in the straight chain, so we are going to call it pent. There is a double bond in the first position, so this is pent 1 in. There is a CH3 group in the second position, so we are going to end up calling it 2-methyl pent 1 in. 2-methyl pent 1 in. So now change this thing up. Let's make it like CH3 has gone from this side to this side. So the CH3 has moved from the carbon in the second position to the carbon in the fourth position. Now we are going to call this, I did not ask you to show up, we are going to call this 4-methyl pent 1 in. এখন এতদিন পর্যন্ত আমরা শুনছি we are going to take the shortest side, but এখানে হঠাৎ করে আমাদের নিয়ম চেঞ্জ হয়ে গেছে. 4 নম্বরেরটা আমি 4 নম্বর বসাইছি, even though if I count it from the right side it ends up being 4. So we are going to prioritize the functional group over the methyl group. The functional group here is the alkene group in. The alkene is in the first position, So our count is going to start from the left side. From the left side, this is the first, second, third, fourth carbon. So this ends up being 4-methyl. So this is 4-methyl pent 1-ene. So if I change things around even further, so imagine a scenario where we have carbon, double bond, carbon. We have something like this. We have C2H5 hydrogen. We have C3H7 hydrogen. How am I going to name this guy? তো এইখানে 3টা কার্বন, এইখানে একটা, সো 4টা, এখানে একটা, 5টা, এখানে 2টা কার্বন, সো 7টা. So this ends up being C7H14. Alkene general formula is CnH2n. So this is C7H14. So this is definitely heptene. I do not know the number of this, so let's count. 1, 2. So if I spread it out, carbon, 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 this is the 4th carbon, so this is the 5th carbon. So 1, 2, 3, 4th bond. This could be hept4-ene, or this could be 1, 2, 3. So this is going to end up being called hept3-ene. This is how we decide the positional isomers. The same thing can happen with alcohols. So let me give you an example of an alcohol. We have carbon, 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 OH, carbon, C2H5. So what am I going to call this guy? Everyone else is a hydrogen. So we count the number 1, 2, 3, 4. So it's a bute if I count it from here. We could count it from this side. 1, 2, 3, 4, 5. So the longest chain is a pent. The second carbon is a hydroxide group. So this ends up being called pentan 2-ol. This guy is attached to the third carbon. So this guy ends up being called 3-methyl pentan 2-ol. So this is how we name positional isomers. If the hydroxide position changes around, we are going to have different names depending on where it is present. So imagine a scenario where the OH is present in this side. Why is this continuously showing up? So we have OH over here. So this ends up being called pentan 3-ol, and the methyl group is in the third position as well. This is 3-methyl pentan 3-ol. If there are any questions regarding any of these molecules, or any questions that you have that you don't understand, like positional isomers, or giving you a tough time, please leave comments below. I'll try to answer them to my best possible knowledge. Thanks. See you in the next one.